Welcome, ladies and gentlemen, to your virtual learning day for college algebra, lesson 1.7, dividing complex numbers. What you see here is two complex numbers where A and B, C and D are all real numbers. I is the square root of negative 1. And so we have two complex numbers, the numerator divided by the denominator. When we divide complex numbers, we're going to get a complex number where x and y here are real numbers. I is the square root of negative 1 again. Okay? We need to review a couple of things before we do this. We need to review first what complex conjugates are and what happens when we multiply complex conjugates. So recall that if I have a complex number, 3 minus 4i, its conjugate is 3 plus 4i. Change the sign on the imaginary part to get the conjugate. When I multiply this, I distribute the 3, and I get 9 plus 12i. And when I distribute the negative 4i, I get negative 12i. Now, positive times negative makes negative 16, and I squared. Yesterday, when we did operations with complex numbers, you would have learned that I squared is equal to negative 1, because the square root of negative 1 squared is negative 1. So your 12i and your negative 12i cancel out. The middle term will always cancel out when we're multiplying by complex conjugates. And our I squared is going to become negative 1. So negative 16 times negative 1 becomes positive 16. So this ends up being 9 plus 16, which is 25. So when we multiply complex conjugates, we get a real number answer out. That's going to be really important. Because when we look at this, if I is the square root of negative 1, then it's obvious when we're dividing complex numbers, we have a radical in the denominator. I is a radical. It's the square root of negative 1. You've been taught your whole life that you can't have radicals in the denominator, that you have to rationalize your denominators, get the radicals out of the denominators. So we need to find something so that we can do to this complex number to make the radical, that I, go away in the denominator. But if we multiply a complex number by its conjugate, the I goes away, the radical goes away. So if we take complex number, let's put some numbers there. Let's go 2 minus 5. What I want to do, if I want to simplify this division of complex numbers into a single complex number written in standard form like this, a plus b times I, or x plus y times I need to get rid of the I in the denominator. To do that, I'm going to multiply by the conjugate of the denominator. That gets rid of the I. So I'm going to multiply the denominator here by 2 plus 5i. But I can't multiply a fraction's denominator by something without changing the value of the fraction. So if I multiply the denominator by 2 plus 5i, I'll also multiply the numerator by 2 plus 5i, so that what I'm really multiplying by is 1. When I multiply a number by 1, I don't change its value, so I can do this. So I start, when I'm doing this division with complex numbers, multiplying the fraction, the division problem, on the numerator and denominator by the conjugate of the denominator. Now I have to multiply the numerator out. So when I distribute the 3, I get 6 plus 15i. When I distribute the 4i, I get plus 8i. And then positive and positive makes positive. And then 4 times 5 makes 20. And I times I makes I squared. In the denominator, when I distribute the 2, I get 4 plus 10i. When I distribute the negative 5i, I get negative 10i. And negative, multiply negative times positive, then 5 times 5 is 25. And I times I is I squared. Let's simplify and clean up the top. Remember, I squared is negative 1. That makes this negative 20. So I'm going to rewrite this. I'm going to go ahead and combine my like terms with the i's to get 6 plus 23 times I minus 20. And in the denominator, My 10i's cancel out. Negative 25 times I squared is negative 25 times negative 1, which makes positive 25. So my denominator becomes 4 plus 25. Now, 6 and negative 20 are like terms. So this becomes negative 14 plus 23i all over 29. Now I'm at a point where I can write it in a standard form of a complex number with a real part and an imaginary part, because the way we add fractions, when we have a common denominator, we combine the numerator, add the numerators, and keep the denominator the same. This is the same as negative 14 over 29 plus 23 over 29i. That's how we're going to divide complex numbers. We'll make up another one. Let's do 1 plus I over 1 minus I. There's understood one coefficient on the I and the negative I here. If I'm going to multiply or divide these two complex numbers, I look and I need to rationalize the denominator. So I know when I multiply complex conjugates, I get a real number, I get a real number out. So I'm going to multiply the denominator by its conjugate, 1 plus I. And if I multiply the denominator by 1 plus I must also multiply the numerator by 1 plus I. And now I'll proceed. Put a line here so we can get this. Doesn't look like we're saying those two are equal. When I distribute the 1 up top, I get 1 plus I. When I distribute the I get 1I plus I squared. When I distribute the denominator, it's 1 times 1 plus I. When I distribute the negative I get negative I minus I squared. Now recall that the I squared is really negative 1. So in the numerator, I have I plus I, so I have 1 plus 2I. Now, I squared is negative 1, so plus negative 1 becomes minus 1. In the denominator, I get the I and the negative I cancel. I have 1 minus I squared, but I squared is negative 1. So this becomes 1, negative 1 becomes plus 1. Up in the numerator, my 1 and my negative 1 both cancel. I end up with 2I over 2. And the 2's cancel now, divide out now, so I end up with just I. So 1 plus I over 1 minus I, what we started with, all reduces and simplifies to just I. That's a pretty neat thing. Let's look at a couple more examples, and then you'll have learned how to divide complex numbers. Let's look at an example where we have a strictly imaginary number in the denominator. So the real part is 0. So let's do negative 5 plus 3i divided by 2i. We still have an I in the denominator. We still have to rationalize the denominator. We still have to get the i's out of the denominator. So we're still going to multiply by the conjugate of 2i. Recall that the conjugate of a strictly imaginary number is just change the sign on the imaginary part, so it's just negative 2i. And if I multiply the denominator by negative 2i, I've also got to multiply the numerator by negative 2i. This one's a little easier because we don't have a lot distributed in the denominator. In the numerator, I multiply the negative 5 times negative 2i to get positive 10i. And I multiply 3i times negative 2i. Positive times negative makes a negative. 3 times 2 makes 6. I times I makes I squared. When I multiply the denominators, it's just 2 times negative 2. And I times I is I squared. Recall again that I squared is negative 1. So we get 10i. And now minus 6 times negative 1 makes plus 6. Negative 4 times I squared is negative 4 times negative 1, so that's just positive 4. Because of our commutative property of addition, we can switch the order here so we get it in the correct form. We have 6 plus 10i over 4. When I split that into two fractions to get it in standard form for a complex number, I get 6/4 plus 10/4 I. And I'll go ahead and reduce those fractions just because that's how you'll see it on the test. But 6 divided by 4, 6 is 3 times 2, 4 is 2 times 2, so 2's cancel and leave me with 3/2. And 10 is 5 times 2, and 4 is 2 times 2, so 2's cancel and leave you with 5/2 times I. So when I divide by a strictly imaginary number, I can do the division the same way. So now let's look at one where we have a strictly imaginary number in the numerator. Let's say we have I divided by 10 minus 3I. Once again, I've got to rationalize the denominator. So I'm going to multiply the numerator and denominator by the conjugate of the denominator, 10 plus 3I. Now, distributing the numerator is easier, but I'm going to take and distribute I times 10 and get 10I. I multiply I times positive 3I, I get plus 3I squared. Again, I'm going to distribute the denominator. 10 times 10 is 100. 10 times 3I makes 30I. Distribute the negative 3I to the 10, I get negative 30I. And when I distribute the negative 3I to the positive 3I, I get negative 9I squared. So in the numerator now, my I squared is negative 1 again. This becomes negative 3. So I have 10I minus 3. Because of the commutative property addition, I can say that's negative 3 plus 10I, so I get it in the correct form. In the denominator, my 30i's cancel. I have 100 minus 9I squared. Negative 9 times I squared is negative 1, so this becomes negative 9 times negative 1, or plus 9. So this becomes 109. Now I'll split it into two fractions and get negative 3/109 plus 10/109 times I. And that is the solution to the equation, or to the division problem, I over 10 minus 3I, the problem I started with. And that is how you you divide complex numbers. So let's look at it again, and we'll list out the steps for dividing complex numbers. The first thing we do, we have a division problem for complex numbers. Multiply numerator and denominator. By the conjugate of the denominator. Then we clean up, simplify the numerator and denominator. And remember, now, because you multiply by conjugates, your denominator is going to be one real number. Then, you split your answer into two fractions, added or subtracted, and get the answer A plus some C plus or minus B over that same C times I. Sometimes one of these fractions will simplify. There'll be a factor and the other one won't. But, so sometimes you may end up with different denominators after you simplify your fractions. But, like we had here, this became a common denominator, so we end up with negative 3/109 plus 10/109 times I. And that's how we divide complex numbers. So now you should have already done your pretest, then you watch this video, then you do your exit ticket, and then you work on your homework. Feel free to email with questions on your homework. Enjoy your day.